Welcome to Inside Insights, your quick hit of tips, tools, and trends for manufacturing, distribution, and Dynamics 365 Business Central. Brought to you by InsightWorks.
Welcome to today's Deep Dive Learner. We are so glad you're joining us. So, picture this scenario for a second. It is 2 p.m. on a Tuesday.
Right, prime time.
Exactly. The warehouse receiving dock is just bustling, moving at max speed, and suddenly the Wi-Fi drops.
Oh man, the absolute worst nightmare for any operations manager.
It really is. So what are the ugly choices left for the warehouse workers in that exact moment?
Yeah.
I mean, they can just stop and wait, right? Or maybe pull out paper and pens.
Yeah, or they just keep scanning blind and, pray that all the errors somehow sort themselves out later on.
And spoiler alert, none of those scenarios end well for anybody.
So
So that brings us to the goal of today's deep dive. We are unpacking a whole stack of sources on resilient warehouse connectivity for Business Central.
specifically looking at how this native extension called Warehouse Insight actually solves this invisible operational nightmare.
Right. Okay, let's unpack this because a 4-second Wi-Fi drop at a warehouse, I mean, on paper, it doesn't sound like a catastrophic event.
No, it sounds like a tiny glitch.
But if your workers are out there scanning serial numbers at their absolute maximum speed, that microscopic 4-second dead zone can easily ripple into, like, a $500 loss by the end of the shift.
Easily. And to understand the fix for this, we actually have to look at the architectural flaw in how most systems handle the whole concept of a connection.
Yeah, because most WMS platforms, they just treat network connectivity as this binary state.
Exactly. The light switch is either on or it is off. You either have a crystal clear line to the server or you are completely dead in the water.
But if you think about a massive distribution center, I mean, it is essentially a giant Faraday cage, right?
Oh, completely. It's just full of steel racks, thick concrete pillars, all this electromagnetic interference.
Right, so that binary thinking is exactly why these systems fail under pressure. Because connectivity in that kind of environment, it's a spectrum. It is not a switch.
Yeah, and the sources actually point out 3 distinct failure scenarios that most warehouse management systems just wrongly treat as the exact same issue.
Right, they just throw up this generic connection lost error.
Yeah. So first you have the hard down, which is a full network outage where the ISP completely fails.
Then you have the micro drop. That's, stepping behind a massive rack of automotive parts and just losing the signal for a few seconds.
And then the third one, which is really interesting, isn't even a network failure at all. It's a high-volume scanning scenario where the physical scanner reads the barcodes faster than the server can actually respond.
The worker is just outpacing the ERP's API endpoints.
Exactly. And treating all 3 of those totally distinct operational realities with the same generic error screen, I mean, it's a massive failure of user experience.
It's like a doctor giving you a full leg cast, whether you have a broken bone or, a paper cut or just a bad cold.
That is a great way to put it. It's a completely blunt instrument.
But wait, I actually want to push back on something fundamental here before we get into the nuances of those 3 modes.
Sure, go ahead.
If the scanner device still physically captures the barcode when it drops offline, like the laser fires the digits actually register on the device, why not just run the entire operation asynchronously?
Meaning what, exactly?
Like just let the operators batch, scan everything, cache all their scans locally on the handheld, and then just push the entire payload up to Business Central at the very end of the shift. What is the actual harm there?
Okay. Well, if we connect this to the bigger picture, the fatal flaw of batching is rooted in the fundamental architecture of Business Central itself.
How so?
Because Business Central's warehouse management philosophy is built entirely around synchronous, real-time data validation.
Right, it wants to check everything instantly.
Exactly. It is designed to evaluate logic at the exact fraction of a second that the transaction occurs. It's validating the item number, it's checking the unit of measure.
Confirming the bin contents.
Yes, and verifying lot or serial numbers against the master ledger all simultaneously.
So if you decouple the scan from the server validation, you are essentially flying blind.
You are creating a delayed reaction bomb. Let's actually play out your batching scenario. Say an operator is picking a really complex order completely offline.
Okay.
They accidentally grab a product with an identical package but a slightly different SKU. Or maybe they pull from a bin that was technically put in a quality hold 5 minutes ago.
Oh, I see where this is going.
Right, because the device is just batching data locally without those real-time API calls to the server. The scanner just silently accepts the bad data. The operator thinks everything is fine and moves on.
And then what happens at the end of the shift?
Well, 2 hours later, they dock the scanner to upload their work, and Business Central immediately rejects the payload. It just spits back a whole series of validation errors, wrong item, exceeded quantity, bin conflict.
And by that point, the operator has probably already shrink-wrapped the pallet.
Yeah, it's probably staged at the loading dock, or honestly, it might already be on a truck. So now, someone has to physically walk all the way down to the dock, tear open the shrink wrap, dig through 80 identical boxes just to find the one specific item with the mismatched serial number.
And then correct the ledger and rewrap the whole pallet. That is a nightmare.
It creates massive operational friction. In a high-throughput environment, backtracking through 10 minutes of work, let alone 2 hours, it just leads to long-term pick errors and huge stock discrepancies. Batching isn't a solution, it's a trap.
Okay, yeah, so a blind local batch is a total disaster. I get it. That firmly establishes why that synchronous baseline is so critical. You need the system to catch the error before the physical item ever leaves the operator's hand.
Which is exactly why Warehouse Insights architecture doesn't just rely on a single fallback. They separate connectivity into 3 distinct modes.
Right, let's get into those. What's the baseline? What does the ideal state look like to prevent all these compounding errors?
Mode 1 is their online-first operation. This is the absolute gold standard, where every single scan triggers a real-time API called Business Central.
And here's where it gets really interesting. In this online-first mode, it's kind of like having this hyper-vigilant supervisor just standing right over your shoulder,
Oh, definitely.
instantly flashing a red light or a green light before you even take your next physical step. If you scan a mismatched lot number, the UI just locks up with a red screen instantly.
And from a business perspective, the financial implications of that are just huge. Catching a mistake at the source costs practically $0.
Yeah, it takes, 3 seconds to put the wrong box back on the shelf?
Exactly. But if that wrong item makes it onto a delivery truck, now you are dealing with return shipping, a furious customer, manual inventory reconciliation.
It's a mess.
So this mode protects the profit margins by enforcing ledger accuracy at the very edge of the physical network.
But as we established earlier, warehouses are not perfect laboratories. They are giant metal boxes filled with interference.
Yes, they are.
So what happens when our ideal online-first baseline hits the harsh reality of a Wi-Fi dead zone? If an operator steps behind a steel rack and the signal drops for 3 seconds, the system can't just throw a fatal error.
Right. You can't just force them to restart the whole application every time there's a hiccup. And this is where we're moving into mode 2, which is the store and forward engine.
Go break that down for us.
The best way to understand this is to think of it as a shock absorber for the network. When you're driving and you hit a pothole, the wheel dips down, but the chassis of the car stays level because the suspension absorbs that impact.
Right.
The store and forward engine does the exact same thing for network latency. When an operator hits a dead spot right in the middle of an aisle, the engine intercepts the scan. Instead of timing out, it securely queues the scans in a local buffer right on the device.
So what does this actually mean for the worker on the floor? On the screen, are they constantly tapping a reconnect button? Are they staring at a spinning loading bar? Because if the UI freezes, you've still interrupted their workflow.
What's fascinating here is that the transition is entirely invisible.
Wait, really? Invisible?
Totally invisible. The main UI thread is completely decoupled from the background network thread. The worker doesn't stop, they don't switch modes, they take zero action. They just keep scanning as if nothing happened.
Wow, so the engine just holds the data in the local buffer.
Yep, and it constantly probes the network connection in the background. The exact millisecond the connection stabilizes, it automatically forwards the queued scans as a batch payload to Business Central.
This makes absolute sense for that high-volume scanning scenario we talked about earlier.
Oh, it's vital for that.
Yeah, say an operator is receiving a massive shipment. They have a box of 500 hard drives, and they have to scan 500 individual serial barcodes. A seasoned worker builds up this incredible physical rhythm. Beep, 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 beep. Exactly. And if the software demands a full server round trip for every single scan before it unlocks the scanner for the next item, the software is artificially throttling the operator. Right. They are forced to physically slow their hands down just to match the server's response time.
Which penalizes your absolute best, fastest operators. Stopping to manage connectivity or waiting for a ping is simply not an option for them.
So with the store and forward engine, the device accepts those rapid-fire scans instantly into the local buffer.
Yes. The operator scans at their maximum physical speed, and the engine pushes the data in the background. The software adapts to the speed of the worker, rather than forcing the worker to adapt to the network.
That's a brilliant way to smooth out the temporary bumps. But we have to talk about surviving the dark. Let's escalate this to the ultimate worst-case scenario.
Okay, let's go there.
A shock absorber is great for a pothole, but it does absolutely nothing if the entire bridge is washed out.
Fair point.
It's 2 p.m., the ISP digs up a fiber line down the street, the warehouse is completely severed from the cloud, and it's not coming back for 3 hours.
Yeah, a total planned or unplanned network failure. That triggers mode 3, which is full offline mode.
How does that work without flying blind?
When the system detects a hard outage, it relies on the fact that existing operational documents, like your pick lists, your put-away instructions, or receiving orders, have already been cached on the scanner's local database.
Oh, so the device already holds the blueprint for what the operator's supposed to be doing today.
Exactly. Workers can still open those cached documents. They can scan items, enter quantities, and complete entire transactions locally.
But hold on, I have to challenge this.
Sure.
Because you just spent the first part of this deep dive totally tearing down the concept of batching. You said it creates a delayed reaction bomb. Now you're telling me that in offline mode, they complete workflows locally, and when the connection restores, the data goes up to Business Central. Isn't that just batching with a fancier label?
It's a really critical distinction, actually. It is not raw, unvalidated batching. First off, because the document is cached, the system can perform preliminary local validation against that specific data set. It knows if you try to pick an item that doesn't exist on that specific order.
Okay, that makes sense. It has some guardrails.
Right. But more importantly, it's about how the system handles the reintegration. When the connection finally comes back, it doesn't violently shove all those offline transactions straight into the master ledger.
Because that would just break everything?
Exactly. It would risk locking the database. Instead, the data flows into a dedicated exception queue.
Ah, so it's a staging area.
Yes. The data goes to Business Central for a worker or supervisor to review exceptions before posting. Most transactions without conflicts will process fine. But if, say, 2 offline operators accidentally picked from the same bid and created a conflict, a supervisor reviews that specific exception, resolves it, and then posts it.
You're isolating the conflicts instead of polluting the live database. That is smart. But that all relies on the operator already having a cached document on their device.
True.
What happens if an unexpected delivery truck rolls up right in the middle of this 3-hour outage? There is no receiving document cached on the scanner because Business Central didn't even know the truck was coming today. Do they just turn the driver away?
No, they don't have to. For that exact situation, they utilize the Scratchpad application.
Scratchpad.
Yeah. The sources detail this as a specific feature for ad hoc entries. If a worker needs to receive freight, ship a pallet, or do an inventory count without an existing document, they open the Scratchpad.
So it's kind of like a digital emergency notebook.
That's a perfect way to describe it. They capture all the raw data item numbers, quantities, whatever they need securely on the device, and then it magically translates its scribbles into the official company ledger the second the lights come back on.
The system matches those raw actions to the right purchase orders automatically when the network restores.
Exactly. It completely eliminates the need for workers to pull out paper and clipboards during an outage.
Which is huge. Because paper introduces transcription errors. Someone writes down a serial number, and 3 hours later, someone else has to try and read their terrible handwriting to type it into the system.
Exactly. Now, this raises an important question about custom workflows, though.
What do you mean?
Well, teams with highly specific needs often have custom apps. What if a warehouse has a highly specialized quality assurance process they've built into Business Central? Does that just break during an outage?
Right, because usually if you hard-code a custom extension, it's completely tethered to the server.
Exactly. But they solve this with the app designer's offline framework. It allows development teams to build their own custom offline apps without even touching the core warehouse insight code.
Oh, wow. So they use this framework to build the custom QA loop, and the framework just handles all the background caching and local validation automatically.
Precisely. It completely separates the physical task from the network status. The software flexes to meet the reality of the floor.
Okay, so what does this all mean when we pull it together? For the listener out there, specifically the end users, I mean, the big takeaway here is that your warehouse never stops moving.
Right. Throughput is protected.
Yeah, and you don't have to trade away real-time validation to get that resilience. The system just gracefully degrades across those 3 modes to keep everything flowing.
And if you are a Microsoft partner listening to this, it provides a highly specific operational answer to that dreaded sales question.
Oh yeah, when the client asks what happens when the connection drops.
Exactly. You don't have to just give a vague answer like, oh, well, we have an offline mode. You can actually explain this invisible resilience. It's
Yep.
vastly superior.
It really is. So if you want to dig into the technical specs of these modes or see how that app designer framework functions, the sources highly recommend visiting wmsfordynamics.com.
Yeah, and they encourage you to connect with a Microsoft partner to evaluate which configuration actually fits your specific warehouse environment because every facility is different.
Absolutely. So, learner, as we wrap up today's deep dive, I want to leave you with a brand new, thought-provoking concept to mull over on your own.
Oh, I like where this is heading.
We've just spent all this time dissecting how Warehouse Insight achieves this incredible invisible resilience. It seamlessly shifts between relying on the cloud and edge device autonomy to maintain perfect flow.
Right.
Well, if software can now possess this kind of invisible resilience, how long until we see this exact same concept applied to human decision-making?
What do you mean by that?
Think about AI assistants. We are moving into an era where AI is constantly guiding our work. Imagine an AI assistant that subtly switches between guiding our workflows when the data is flowing, and then the moment the server drops or the data runs dry, it just seamlessly steps back.
Oh, wow.
It stops prompting you and quietly allows you to run on your own cached human expertise, buffering your actions until the connection restores without you ever even noticing the handoff.
That is a fascinating parallel.
Right. If a warehouse scanner can manage that kind of graceful autonomy today, the implications for human-computer interaction tomorrow are just massive. Something to think about. Until next time, keep digging deeper.